inverse operations in logarithms. I see these formulas that says when you have find the log of b, where the base is also b, and b is raised to the power of n, the answer is n. And also, if you have b raised to the power of log n when the base is b, the answer is also n. Is that so? Let's see how these work and discuss them. I didn't number these. Not number, letter. A, B, C, D, E, F, G, H. All right. Let's see something here. Let's look at part at A. This one. You have log, the base is 10, and the number you're logging is 10, and it's equal to x. Now, let's see if we can change them to index form and see what will happen. Now remember, the index form, you want to remember how to change from log to index form or index to log form. Just say the log of 1000 is equal to 3 and the base is 10 and 10 to the 3 equal 1000 and follow the pattern. So here now, the base is 10 in log, the base is also 10 in the index. You say equals x. This says equal 3 and in the index form is the number that's for the power. So it's 10 to the x equals 10. But 10 to the x, when you say 10 to the x equal 1, no, 10 to the x equal 10. You know that 10 to the 1 is 10. So x must be equal to 1. All right. So say this is equal to 1. Now notice this 10 has a power of 1. So the first formula here seems to be working so far. Let's try something with the second example and see what we will get. B. This is what we're doing now. The log base 10 of 10 to the power of 3 equals x. Change it to index form. We say 10 to the x is equal to 3. No, is equal to 10 to the 3. 10 to the x is equal to 10 to the 3. Oh, the powers must be the same, so x must be equal to 3. Understand that? So in this case, x is equal to 3. Same as this. And you see that it's working just like this. Alright? Let's look at letter C. The log with a base of 2 and the number you're logging is 2 is equal to x. In index form, 2 to the x equals 2. What do you say? 2 to the power of x is equal to 2. 2 to the what equals 2 to the 1. Because 2 is just 2 to the 1. So in this case, x is 1. So x is equal to 1. So can remove this x and put 1 there. Because this 2, the power of 2 here, is 1. Alright? And you can see that. Now, let's look at the other one. D. We're saying the logarithm of 2 to the 4 with a base of 2. It is equal to x. Change to index form. We say 2 to the power of x is equal to 2 to the 4. Oh, but x must be 4. So x is equal to 4. Alright, quite interesting. So you see this and this is the same. So if you're finding the log of a number and the base of the number is the same as that number that you're finding the log of, and that number is raised to 1 power, the answer will be the power itself. Let's see how the other ones work out. What we have here, 3, the log base 3 of 3 squared, the log of base 3. The log of 3 with a base of 3 squared is x. 3 to the power of x is equal to 3 squared. 3 to the x is equal to 3 squared. So x must be 2. The same 2 here. So in that case, x is equal to 2. Nice. Now let's look at the other one. Oh, we're saying 10 raised to the power of log 5, where the base is 10, equals x. So let's see now. We want to rewrite this from index to log form. We have 10 raised to the power of log 10, log base 10 to the 5 is equal to x. Now, here, the base in the index form must be the base of the log. Oh, no, here, what you're going to do, we're going to look at the fact that when you have, oh, my mistake, this should not have been 5. I wrote the wrong thing here. It should be 1 and 5 zeros. Right. Instead of, it should be 1 and 5 zeros, which is 10 to the 5. Alright. Right? It's 10 to the 5. Or I could even write the 1 and 5 zeros. Same thing. Right? 1 and 5 zeros would be what? 100,000? 1, 2, 3, 4, 5. Let me erase part of it and put some more space here. 10 to the 1, 1, 2, 3, 4, 5 equals x. Right. So that's what I should have. My. So 10 raised to the power of log of 100,000 with a base of 10. What would that give? So let's start again. Now here, we could rewrite this as 10 raised to the log with a base of 10 of 100,000 is 10 to the 5. Right, that's it. Well, let's look at this part here. If we consider this, the log base 10 of 10 to the 5. Based on the laws of log, this is 5 log base 10, log of 10 with a base of 10. You see that? Alright. Now, here, what you have, therefore, remember, this enough, is this, all of this. So what you have, therefore, is 10 to the power of the logarithm with a base of 10. Normally, you don't write the 10, but I want to emphasize it there. You don't write the base when the base is 10. Once you see log, you can safely assume that the base is 10. But if you see log with a base, well, that's not base 10, that's whatever base they say. But once there is no base specified, you assume it's base 10. But anyway, we put the 10 there to emphasize. So, log base 10 of 10 to the 5. But hold on. Based on the laws of logarithm, what we have here is 10 to the 5 log base 10 of log 10 with a base of 10. But the question now is, what is log of 10 with a base of 10? If you make this equal to a, and you change it to index form, you're saying 10 to the a is equal to 10. 10 to the what give you 10? It's 1. So a must be 1. So this equals 1. You follow? Make sure you follow, you know. So what we have is 10 to the power of log 10 to the 5, the base is 10, is equal to 10 to the 5 times 1, because this, as we saw a while ago, is 1, right? So 5 by 1 is 5. So therefore, 10 raised to the power of the log base 10 of 10 to the 5 is equal to 10 to the 5. Alright? So, what you have is this here and the same thing here. Does it agree with what we had? We say 10 to the log base 10 of a number equal the number itself. Is it so? 10 to the log of a number. B to the log of a number with the same base b is equal to the number itself. Right, it worked out. It worked. Alright? Now, let's look at the other case. So in this case, what we found is 10 to the power of 10, which is 100,000. 10 to the power of 5, which is 100,000. What about this? Would it really work out? Suppose you say 2 raised to the power of log 64, and the base is 2. And that is equal to x. Would that really work out? Let us see. Let me write this 2 bigger than the, significantly bigger than the rest of it. 2 raised to the power of that equals x. 64 is 2 to the power of what? 2 2s 4, 4 2s 8, 8 2s 16, 16 2s 32, 32 2s 64. It's 2 to the power of 6. So you can write this as 2 raised to the power of log 2 to the power of 6, where the base is 2. And that is equal to x, right? We're going to find out what x is. But guess what? This, based on the laws of logarithm, you can rewrite it as 2 to the, you find log of 2 to a power, this is power times log of 2. Remember, the base is also 2 equals x. But then, this thing jumping up and down like that. But then, the log of 2, where the base is 2, is equal to 1. If you change it to index form, you're going to see. So it's 2 raised to the power of 6. Why did I write 0 here? It's x. It's 2 raised to the power of 6 is equal to x. So the answer is 2 to the power of 6. So it is 64. 2 to the power of 6 is 64. 64. Alright? So 2 to the power of log base 2 of 64 is 64. B to the power of log base b of n is n. Alright, it worked there in that case. Let's try this last one and see what would happen. I'm going to try h. Now here we have 5 to the power of the logarithm of 625, where the base is 5, right? And that is equal to x. Let me see something here. This is 5 to the power of the log with a base of 5 of 625 is Can it be written as 5 to a power? Let's see. 5, 5, 25. 25, 5, 125. 25, 5. 625. So there are 1, 2, 3, 4 5s here. So 625 is 5 raised to the power of 4. And that is equal to x, right? So we have that. So now, what we have here is 5 to the power of. You see this part here? We're finding log 5 to the 4th power. So this now is 4 log 5. Remember the base is 5. Alright? Oh, not there. 5 here. Equal x. But log of 5 with a base of 5 is 1. You can try it and see. Change it to index form and you'll see. So 5 to the 4 times 1, which is 4, equals x. So x is 5 to the 4th. 5 to the 4 is 625. So x is 5 to the 4, which is 625. So we're saying 5 to the log of 625, where the base is 5, is 625. B to the log of n, where the base is b, equal n. Alright, good, good. So these are what I call inverse operation. You see, when the reason why they say it's inverse is because when you find the log with a base of b, log of b with a base of b, you're really looking at the fact that log with a base of b is the reverse of b to the n, right? And b to the log b to the n is equal to, is the inverse. You are b to a number is the reverse of log base b of that number. So here, if you say the log of 1000 is equal to 3, the base is 10. Alright? If you raise 10 to the 3, you get 1000. These are inverse. Sometimes when you say 10 to the 3, you call it the anti-log. Alright? The inverse of log, finding log, is sometimes called the anti-log. So you find the log of 1000, you get 3. Raise 10 to the 3, you go back to 1000. Alright? So in this case, you find the log of this number b. Find the log of b, you get an answer. Raise, and the base is b. Raise b to that number and you get back. Or raise b to that answer and you get back a number. Log of b to the n. Give you an answer. So the log is b. b raised to the answer give you back b to the n. Right? One is going one way, the other is going the opposite way, wiping out what the other one did. So they are inverse operations. Alright, I'll see you in the next video.